Okay, so now the last 6 bits or the flag field values we are going to have are the SYN bit, FIN bit, reset, push, and urgent and acknowledgement. So each has a specific purpose. Now the SYN flag and the FIN flag are used to establish a TCP connection and tear down a connection. Okay, and the acknowledgement flag is used to indicate that packet that is part of the so this ACK flag is in the TCP header. So the corresponding packet is like an acknowledgement, not a data packet. So the acknowledgement flag is set to 1. That's what it means. It indicates it's an acknowledgement. Okay, so now the reset. Now we'll see the TCP connection establishment quite soon in detail. Now the reset flag is used to terminate a connection. So if a connection is going on and the sender doesn't want to send any more packets, so suddenly if it wants to close the connection, it can use the reset flag. Now the FIN flag is to terminate a connection in the normal way. It's called tear down a connection. As the reset flag is used to do what's called abort a connection. That means you just want to suddenly close a connection. Now the push flag is to indicate to the receiver that the segment that is accompanying the corresponding TCP header is sent down just suddenly, in the sense that, let me show you here. Okay. So there are 3 ways a segment could be triggered for transmission from the source. So I thought I had a slide for that. I think it is here. The same thing. So the application process at the sending side could keep writing bytes to the sending buffer. But it's not that every time you write a byte or a set of bytes, the sending process is going, the TCP protocol at the sender side is going to send the bytes as a segment. So the sending of the transmission of a segment is triggered. It could be triggered due to by these 3 ways. One is you wait for a certain amount of bytes to get collected. If you have that amount of bytes, it's called the MSS, maximum segment size amount of bytes collected, then you can send a segment. So that's one way you can trigger the transmission of a segment. So that's the normal way. Now you can also make it like periodically. So for every certain time you want to send a segment. So in that case, whatever the amount of bytes got collected, it need not be the one full maximum segment size. So say for every 10 seconds you want to send a segment. So then for every 10 seconds whatever bytes have got collected, if they can be within the maximum segment size, you put together as a segment and send it. So it's also a normal sending process. Now the other way is if the application figures out that whatever the bytes it has returned to the sending buffer have to be transmitted right away. Without waiting for one MSS amount of one maximum segment size amount of information to be collected and so on. So it can trigger that. It can do this called the push operation. So it can make the TCP protocol running at the sending side to just send the segment right away. So that's called the push operation. So in order to let the receiver know that this particular byte or sequence of bytes were received in the segment have been sent as part of a push operation, you set the push flag to 1. Now also there is another flag called the urgent flag. So if the urgent flag is set, that means the data that is part of the segment has some urgent information that needs to be processed. So typically the urgent portion of the data is included in the first part of the data payload. Remember the TCP header has the payload. So you include the urgent portion of the data as the first portion of the data and the non-urgent portion as the remaining part of the data. So you include, if you set the urgent flag, that portion of the data, of course there is an urgent pointer field. The urgent pointer field will indicate what is the starting byte number for the non-urgent portion. So using that urgent pointer field, you can figure out, until starting from byte 0 of the data, what is the urgent portion of the data, and you can process that urgent portion. So if the data has the urgent portion that needs to be processed right away, then you can set the urgent flag. Okay. Then, so we covered all these 6 flags. So the ACK flag is to indicate that this is an acknowledgement packet. Okay, so now just want to make sure about the MSS. So how to calculate the maximum segment size? So we all know what is MTU. So MTU means maximum transmission unit. So that is the IP header size plus the datagram. Okay. So the MSS is the MTU minus the IP header size plus the maximum TCP header size. So that is the formula to compute one maximum segment size. So this is the amount of data. So when I say MSS, it is the maximum amount of data that can be included in a TCP segment. Okay. So as I said, the possible ways for triggering the transmission of a segment is you wait for one MSS amount of information to be accumulated in the sending buffer, and you can send that, or you run a timer, and for every time period you can send one MSS amount of information or one segment, or it could be the push operation that could trigger the transmission of a segment right away. So these are the 3 ways a segment could be triggered. Okay, so let me make sure we have covered everything here. Alright, so now another purpose of the, okay, let me go back to a TCP header. So we covered the flag field. So now we have the advertised window field. So the advertised window is used by the receiver, by the destination, to indicate to the source what is its available buffer space. So we have 16 bits for the advertised window. So you could notify a buffer space as large as 2 to the power 16 minus, 2 to the power 16. These 16 bits you can indicate to the power 16 bytes that this is my buffer space. So if your available buffer space is more than 2 to the power 16 bytes, okay, because nowadays you have computers coming with larger memory. So if you want to advertise more than 2 to the power 16 bytes, you again make use of the options field. So this is what I indicate here. So that's called, like, I can make use of what's called a window scaling factor. So let us say you want to indicate you have space for 80,000 bytes, which is more than 2 to the power 16. 2 to the power 16 is 65536. So if you want to indicate your available window space is like 80,000 bytes, which cannot fit within 16 bits, what you can do is you find what is called a scaling factor that can be used along with the advertised window. So the scaling factor, of course, has to be an integer. So if for 80,000 bytes, if you say the scaling factor is 4, then 80,000 divided by 4 is 20,000, which can fit within 16 bits. So you indicate 20,000 as 16 bits in the advertised window field, and then use the options field and use the 32 bits options as a scaling factor. Okay, so the options field, again, you can have 10 rows of options, because the maximum header length could be 60 bytes, the minimum is 20 bytes, so which are these 5 rows. So the options can be 10 rows. So one row could be the Windows scaling factor. Now, so again, you might have figured out that there's no one single answer for the scaling factor. For 80,000 bytes, I could make 4 as my scaling factor and put 20,000 in the advertised window. I could have 8 as my scaling factor and put 10,000 as my advertised window. So you could come with any combination, that's okay. Okay. So these are the possible ways you can use the options. So we saw 3 ways. One is to use the scaling factor, And also sometimes to specify, I think I did not mention this. So if you want to tell the other side what is the maximum segment size, you could indicate that in the options field also. And then the timestamp for the sequence numbers to avoid being rounded up and avoid two outstanding bytes to have the same sequence number. You can have a 32-bit timestamp that is coupled along with the 32-bit sequence number to make it really a large space for unique sequence numbers. Okay, so these are different uses of the options field in the TCP header. Right. So again, the checksum is computed on all the field values in the TCP header along with the data, as well as the source and destination IP address in the IP header. Okay, similar to how it is done in the UDP header. So the urgent pointer already saw, it indicates if at all you include some urgent data to be processed, you include that as the first portion of the data. So the urgent pointer value really correspond to what the byte number corresponding to the non-urgent portion, the starting byte number corresponding to the non-urgent portion. So these are the different field values in the TCP header. So you need to know the details of each one, how they are being used. Okay, so now what we are going to do is, let me stop here for a minute and save this video.